Okay, you all, this is the last video that you have to listen from me. When we're finding the area between curves, the region must be enclosed. Now, when they're referring to area between curves, this does not mean with respect to the x-axis. This is actually two curves that have nothing to do with the x-axis. So sometimes you will be given the interval for which you must account for, and other times the two curves intersect. So if you are not given the interval, you must see where the two curves intersect by either setting them equal to one another and solving them algebraically, or graphically by using intersect command on the calc menu. Regardless of how you go about doing these, your first step is you have got to graph them, because you've got to see the curve that, with respect to the enclosed area, is to the top, to the north of that. So in this first problem, I need to find the area between these two functions on the interval from 1 to 4. So first thing I'm going to do is I am going to go graph them. I know I've got them labeled, but let's go see them. I've got 7.2 second ln e to the negative 0.07x. And in y2, I'm going to put the other one, 2.34 second ln for the negative 0.11x. Now, something peculiar about your calculator. It will always graph what's in y1 first, always. So you have to be watching this. So let me ask my calculator. I'm going to do zoom 6, because I don't know what I've done. So that's what was in y1, which is the f of x, and this one is my g of x. So this is why I labeled them like I did. Now we're going from 1 to 4. So I want this enclosed area right here. There's no way I can do it on the calculator. Not yet. Just give me a second on that. So in order to do these problems, we've got to set up the interval, and you set them up with respect to their relationship, how these curves are related to one another, in that who is the curve that's on the top of the shaded region. Well, it was f of x, so I've got to take my f of x minus my g of x from 1 to 4. You need to go and see if you can integrate this and get this, because then the next thing I do is I'm going to be substituting like I've done before. 4 in for this expression, then I'm going to substitute in 1 to this expression, and that should be my total area. Okay? So you need to try that and see. Now I'm going to check myself. Now the steps for this is, I don't know if it's on the next page, but if you remember, we've done this. Put this expression in y equals, this whole thing after the integral sign. So I've got 7.2. Let me go, well, I can't use that. I've got to use my cursor this way. I always try clicking on my calculator. It doesn't work. So 7.2 minus, now I'm going back right here, put this part in, so minus that 2.34 second ln to the negative 0.11x. Let me clear this. I don't need that anymore. So let me ask my calculator to graph this part. So now you see my calculator has combined these two. Okay, so now I've done this part. Second, trace for the calc menu, number 7, and let me go from 1 to 4, which are my values that I've got back there, and let's see if my shaded area jives with what I've got. There it is. Remember, I do like checking myself. Well, let's see the next problem. They want us to find this area. Okay, so let's go graph. I'm going to go to y equals, clear that one out, and I always put in the first one they give me. So x squared minus 18. Remember, that's a parabola. I'm going to put in x minus 6 straight line. Now watch, first one that graphs will be the one I put in Y1. So I'm going to elongate my Y min a little bit so I can see where it bottoms out. Really don't have to, but it'd be a prettier picture. Let me try -20. And usually when I start moving those values up, I also change my scale. There we are. Okay. Now this, if you'll notice, is my enclosed area. The curve that is on the top of this enclosed area is my straight line. So if I do top curve minus bottom, it's going to be x minus 6 in parentheses minus x squared minus 18. But the only other problem is, unlike this problem they gave me earlier where they gave me the interval, they didn't here, and that's usually an indication that this thing will intersect. So let's go find our intersection. I'm going to go find that one. So second, trace for the calc menu, number 5. So I always go to my left first, so let me move it to where it looks like it's in the vicinity. And then I hit enter, enter, enter. Once you move it to the vicinity, you don't have to move the cursor again. So that first intersection, -3, -9. Let's go get this other one. Second, trace for the calc menu, number 5. Move my cursor over. Keep my finger down on it. Oops. Let me go back. Let me get in the vicinity. It's pretty close. You've got to get to the word intersection. So this was -3, -9. That's 4, -2, and I believe that's what I've got here. Okay. Since an interval was not given, you must find where the two curves intersect. They intersect at those particular points. Therefore, lower limit, remember we're doing it with x, is -3 and upper limit's 4. Also, the top curve is the linear equation, so the integral should look like this. Do a little bit of cleanup. Cleaning up is less things you have to worry about. So I cleaned it up, then I went and integrated this like we've done before, substituted in my values, and I came up that my total area is 57.167 approximately. Well, for me to go check, let me go to y equals. I'm going to do an insert here. See, you've got to delete and an insert. And an insert saves you a little bit of time because I want to put this piece in, not this one. I want to put this one in just in case I might have, made some errors. So second insert, parentheses, x minus 6, minus, I need parentheses. Remember, be careful with the parentheses. You definitely need it at the back end expression. Let me go clear this one out. So now I'm going to ask it to graph. There it is. Now I've got to move my window the other way. So let me go back down to my Ymax. I just really like to see all the coloring. I think if I put 15 in, that should be sufficient. There it is. And we're going from -3. Now this is not a coincidence. Notice that we're going from -3 to 4, and that just happens to be every bit of the curve that's above the x-axis. So second trace for the calc menu, number 7. So -3 to 4, and let it color. So there's my 57.167. This 343/6 is exact. That's the area on the nose. But you do need to change it to decimal so that when you check yourself, you can verify that's what you've got. Let's see. Got another problem. Determine the area bounded by the given curve. So I need you to graph those. Notice I'm not given an interval, so they do intersect. So see if you can find, make sure that this is f of x and this is g of x, and find out where they intersect. So pause me and go do all that. So you should have found out that they intersect on the left-hand side at negative 3, 3, on the right-hand side 3, 3. So now I need you to set up the integral. Remember who f of x and g of x. This is the enclosed region here, that football-looking shape. So figure out who's on the top of the shaded region and who's on the bottom, and set up the integral, and see if you come up with the following. So the top curve minus the bottom curve, clean it up and integrate. So we come up with 72. If you graph this piece or even this piece, and go on using the second trace for your calc menu, number 7, to check. And if you'll notice again, it starts at negative 3, it goes to 3. So that would verify your interval here. Okay? So guys, that's it. So practice these problems